So welcome everyone to my presentation of partnering to build ecosystems, which are the focus of the talk, looking at resilience and building long-lasting value, and also the evolution of ecosystems and how what partnering plays a role in that. I'm Muslim Elkotob from Vodafone, principal solution architect. Let's get right into it. So first of all, we're going to talk about the journey for large operators, CSPs, from telco to techco. What does that mean? And what is the transformation and the trend that is underneath this change? Then we're going to look at ecosystems in more detail. First of all, ecosystems are they play a role of a key, let's say, driver for business models, and they also are undergoing transformation as stakeholders evolve. And also, there's also the disruption trend, meaning that ecosystems are being, let's say, more exposed, opening the floor for more players of the same kind, for example, like vendors or software providers, and how this all affects the dynamics and the partnering landscape. Then I'm going to talk about Csp Center Ecosystems, so communication service provider, large operator, likes of Vodafone or Orange or any operator you want, and ecosystems which were classically built around that central stakeholder, which is the CSP, versus what we are seeing more and more, what we call open ecosystems. So when the floor is open and there is no more coupling or binding, and there is say more desegregation, I'm going to touch upon that aspect. And then I'm going to talk about, let's say, the core of today's topic of this keynote, partnerships in an ecosystem. So how do you close the value chain? Meaning that there are many stakeholders which form an ecosystem together. There is value which is delivered to customers, and then there is business value. So how do we close the whole value chain so all stakeholders have, let's say, their share of the work, their share of the revenue? What is the optimal way of, let's say, workload sharing among stakeholders in that ecosystem, and how is a proper revenue split in there? Because everybody wants to do the least work and to get the most revenue. So how to balance that aspect. And then I will give some examples from my own work on balanced ecosystems. One of them is going to be on asset sharing and Testbeds federations. In a very advanced scenario, I'm going to talk about that in detail. Then I'm going to give you some insights into another example, which is data-driven services and telco data space. And finally, I'm going to conclude with some, let's say, takeaways and wrap up. So moving on. So first of all, from telco to techco, the classical ecosystems that we have seen, they have been very often built or centered around the operator or the CSP, meaning that there is a large operator in place, and this operator does some static agreement with one or two default vendors or technology providers, and then there is possibly a regulator somewhere, and then you define the spectrum that you offer the services to your end users, etc. And now we have, let's say, more and more change in that landscape. So we have what we call, besides the vendors, which can be now multiple, as I will show, and not a single vendor which wants to lock in the operator or the other way around. You have also what we call ISVs, independent software vendors. So as you have aspects like AI, artificial intelligence, ML, machine learning, you have very specialized aspects in functional areas like, let's say, security, quality of service. You have specialized or analytics. You have specialized software vendors in specific, let's say, algorithms or scopes that deliver excellent software, and you may need several of those to fill in your ecosystem. So ISVs are emerging, they're becoming more competent, they're taking away the share of the, let's say, incumbent players, etc. So that's one thing that we are seeing. Another thing that we see is that the roles of stakeholders in an ecosystem and the ways that they interact, meaning that how does, let's say, an operator interact with one or with multiple vendors? What are the interfaces? Where is the demarcation? Meaning, where does the responsibility of one stop and the other one start? And also, this constant transformation, meaning that as you develop competence and you push either up in the service or application stack, you push upwards. As a telco, if you do more software IT, you go up the stack, you lift up from the, let's say, the bit pipe or the connectivity aspect, which is the next point here. So this transformation always changes the demarcation, the limiters between stakeholders and how they interact and what space they occupy. And this is then the next point here. So classical connectivity, which is of course the basic aspect that has to be in place, or what we call, let's see, if you have more advanced connectivity setup, we can call it underlay, maybe borrowed as a term from the software-defined WAN context with underlay and overlay. But underlay is, let's say, the foundation. And then telcos, they really have to go up from that, let's say, underlay level to more advanced, let's say, ways of offering their services. We've seen that in other keynotes. So you have to go more into IT as an operator. We start also, not only us, but many others are offering already apps. They are, let's say, shaping their service spectrum as a platform-based, let's say, way of operating. And there's more and more, let's say, exposure of services and packaging everything as a service, meaning that managed services are very much in demand, and an operator cannot forever, let's say, delegate doing managed services to other players, because then they will have no part of the value chain to occupy. So managed services are a key thing. And how do you structure services? How do you really package them? How do you load them? And how do you, let's say, in an, let's say, agile or dynamic way form the service that you offer based on the customer demand? This is what is evolving, and this is where telcos are actually heading in order to really keep their space and grow in that respect. So this is the new way to go, as I call it here, for CSPs. Key drivers for transformation include what we've also seen already. It's the ecosystems opening up. For example, you have things like Open RAN, Cloud RAN, virtualized RAN. You have things like from Etsy, the Mano management and orchestration. So we have many aspects that are driving the ecosystems to be open, to break apart the static connections and to allow multiple interfaces between two stakeholder types, or to open the floor for more, let's say, players to come in. And some of them are disruptive players, because if you have, let's say, specialized ISVs in AI or with some specific algorithms or for a specific use case in analytics, they can come in with their software, and the network is becoming more, let's say, platform for software, and they can put in their software to really improve the let's say, the overall application or service quality and add value to customers. So this is the trend that we are seeing here. And as I mentioned before, the shift in demarcation, meaning where does the responsibility of one stakeholder end and when does the other one start? So the demarcation lines are shifting among stakeholders where they meet. And of course, this all powered by what we call desegregation, meaning that breaking up classical connections and opening the opportunity to make a lot of mix and match models. So you pick up your best-in-class components from whoever that stakeholder may be, and you put them into your overall, let's say, platform space. And then this forms, let's say, the core of your ecosystem on the CSP or outside the demarcation lines. This is actually how the transformation from classical telco telecommunications to techco, technology company, is happening. And then to talk about ecosystem, touch upon briefly on this point. So ecosystems, they are, let's say, the key process or flow that enables new business models, because as they evolve, they open up the chance to build new business models. They undergo transformation, and also they are subject to disruption, meaning that in a good way, disruption meaning that the best in class can come in and they can be part of this ecosystem and then occupy their space and change the demarcation lines. And then in this category, I'm going to talk as well about Csp Center Ecosystems and about open ecosystems. Here, just as an overview, for example, the aspect of Mano management and orchestration. This is derived, let's say, from Etsy, the SDO, ETSI, NAV, where you enable with this architecture, with this model, to make any stakeholder, including an operator, to run its own orchestration, not to be obliged to onboard, let's say, an orchestration partner and to manage, let's say, the assets on a virtualized or a cloud platform. So this is how ecosystems are, let's say, taken to a new level where you can really orchestrate your own assets as an operator, which, let's say, is not only important, but also essential to keep up with the pace. Then you have what we are already seeing for quite a while now, what we call a multi-vendor architecture, meaning that, as you can see here on the left side of the slide, so before it was a single vendor, predominant or almost like incumbent for the binding the operator to all its aspects over the whole end-to-end chain. And now we are seeing multiple vendors. Then you have the aspect of software hardware segregation, meaning that you can have, let's say, one or more hardware vendors. On top of that, you have one or more software vendors, and you can mix and match depending what best suits your, let's say, ecosystem and your demand. For example, you can have, let's say, a thin cloud-based slice of a core in 5G, where you don't want to, let's say, load the business case with all this hard equipment, or you really want to use two different, let's say, features from different software providers on the same hardware platform. That should be also possible. That's becoming more and more, let's say, the case. And this is how, let's say, we move towards many open, let's say, models, including the Open RAN model, which is shown in the lower left corner here. And then when there's always been, since 5G came into place, now we're in 5G and beyond in that era, and it's already scratching upon the 6G service. So there was always this big discrepancy between use cases and business cases. UC stands for use case, BC is business case. And we've had this challenge also as operators, because what does an ecosystem? Ecosystem means to me that you have all the players that take part in some scenario, and the ecosystem is sustainable in the way that there's revenue made, there's some business value added, paid by customers. That's the business case. And there's a big discrepancy since 5G came into place between very nice, numerous, amazing use cases, but very few corresponding business cases which really, let's say, have sustainable value and which are not, let's say, with the right figures for an operator. And that's why it's quite a challenge until operators could find what is really a viable business case they can work on, despite having for each business case maybe 50 interesting use cases. What we've worked with so far are, for example, the use case of campus networks, which are any closed or private or integrated space. And where it started to become commercial is what we call Gigafactory. In Vodafone, it means that it is planned automation with 5G, complementing or let's say pushing out all the technologies for industrial, let's say, plants, manufacturing with robots, with IoT. So this kind of factory automation is the business case that has, let's say, prevailed, but all the other forms of campus networks were not really, let's say, a case where you can make money or even not lose money. Then we have other cases like, for example, use cases with the racetracks and automated capturing of multimedia content, audio and video. And the business case that we are putting in place, which is hopefully going to prove to be profitable, is autonomous driving, where it's been quite a long path that we are going there. It also depends on regulatory aspects as well. And then there are other examples like, for example, face recognition, surveillance, all what you can do with drones, cameras, and numerous amounts of data. And public safety is the one which we're going for to be, let's say, commercially also sustainable there. This is just a quick glimpse of, we talk about slicing, and as operators, of course, we structure in the ecosystem our, let's say, individual workflow steps or our service elements in what we call slices. Slices can be in any kind of topology, whether it's hilly or flat or complex. It can be a short slice, more local, or it could be a long span slice, end to end through all the segments of an operator, like radio access transport, backbone, and the end part, which is the data center backend or the enterprise premise. Then moving on to give you an example of because I mentioned that there is the Csp Center Ecosystem type with private and public 5G networks. This is an example here. So you have what they call MPN is a mobile private network. It means that many verticals that we work with, whether it's manufacturing, retail, even public sector, or any kinds of enterprises in the automotive or chemicals, pharmaceutical space, they often want to have a closed 5G network, which is not connected densely, but through specific interfaces to the global network. And NPNs or private 5G networks, this is a special kind of ecosystem, which is part of a larger space. And this has its own, let's say, challenges, how to connect it, how to really, let's say, maintain the KPIs inside and in the interactive phase when this NPN talks to the outside world. And then, of course, as I mentioned, use slices to connect any closed, let's say, 5G cloud or private network to the outside. So you can have local slices inside and you can have long haul slices to the outside public network. And those slices, they have to, let's say, correspond to certain KPIs, quality parameters. They have to comply with certain high demanding requirements. So in the end, you see an ecosystem per vertical of many different MPN clusters, which are interconnected in a special way with some requirements. And then how do you maintain, let's say, the operation and the performance parameters inside each block as shown here, medical industry vertical, and also through the slices that communicate to the global network. This is an example of a Csp Center ecosystem here. And it's a mix, of course, as I said, of private and public 5G networks. And this is a challenge in itself. And as this, let's say, ecosystem aspect evolves, you have to partner with different players because, for example, in order to, let's say, go to one vertical, you need a partner which is, let's say, good in this logistical aspect. So you need to partner as an operator, as for example, Vodafone, with that partner. If you go to a different vertical, there's another challenge. So here, depending which vertical you go to, what are the specifics, what is the context around even a closed space like an MPN, like a premise or headquarter or any site, it then determines which partner you have to deal with, and then how do you interface with that partner. So this is, let's say, an ongoing and living and growing process that we have every time we have new customers we want to add for such a mix of 5G networks. About the partnerships aspect in an ecosystem in general, first of all, you need partners to close the value chain. For example, when we do AR and VR, so augmented reality, virtual reality, we need, of course, let's say, partners which have the equipment for that, which, let's say, leverage upon or interface our, let's say, 5G network and its basic, let's say, maybe apps or interfaces. So then an ecosystem, you always have to find the right partners. And then these partners, then there's, let's say, a workload to share. Of course, also you have to be towards your customer consistent towards the outside as one interface. So a customer is using AR and VR services for any kind of scenario. I have to have a single interface for, let's say, fixing problems, having operational, let's say, solidness, etc. And that's why you have to really define the processes with your partners in the ecosystem, whether it's, let's say, a vendor for AR equipment or it is maybe several partners. And then how do you share the revenue and the workload? And this is one important aspect. What we call here service assurance is exactly making sure that the customer KPIs are met, regardless how the stakeholders interact with each other. It has to be towards the outside, a consistent interface, consistent, let's say, interaction with the customer to solve any problem, and that's the way to how it should go. And the functional scope of an end-to-end turnkey service, what is often required to have a turnkey service completely packaged, is achieved by the what we call the best fit principle of a stakeholder, followed by integration demarcation. So you look at what space do you cover from the spectrum required by the customer as an operator. What do you like? What are the gaps? What is the best match to fit in this gap? How do you really define the demarcation with these partners? How do you integrate everything into a single service? And then that is your offering, your solution that you offer here. And of course, the balance between the share of work you do as a stakeholder and the share of revenue you get, it should be in a sustainable form to be, let's say, a fair model. And this will be then sustainable, of course. And I'll give 2 examples of balanced ecosystems, which I would like to share with you, as I mentioned in the outline. One of them is what we call federated testbeds and asset sharing. I was very happy to see that, I think Juan Carlos mentioned standardization. In ITU, I'm a vice chairman of a group on federated testbeds and assets, where we're exactly looking at this aspect. So how do you, for example, as a stakeholder, suppose you have, let's say, an operator or a stakeholder left and one right, testbed domain X and Y. So 2 stakeholders, they want to, let's say, share assets or use each other assets, because you cannot have everything yourself. You want to close the value chain. So what you do is that if I'm an operator, I'm lacking some resources, I need to borrow something. I need to be able to, first of all, let other operators or other players or stakeholders expose the assets they have so that they can be discovered, like in a catalog or in a, if you want, yellow pages kind of format. At the same time, the operator, myself, who needs assets, should be able to discover them. And then when you discover assets, you define an interaction model on the commercial side. Let's say, what do you pay per use? What is the, let's say, the conditional frame to use certain assets from another player? And then technically, what we've also seen in previous talks are the APIs through which you access, let's say, specific assets. As you can see here, in the testbed context, there are, let's say, different blocks of resource and assets in each bubble. And then what are the reference points? It means that what is the address? Where do you meet a specific asset? Through which API do you access that? And how do you really use this asset? This thing is all being systematically defined, and we're working on that in ITU. Not only ITU, but that's one of the groups that we were driving this. And this is a model where an ecosystem is extended through federation, meaning that I don't have the resources myself. I want to use a pay-as-you-go model. I look around, I discover, I federate, build a connection to I federate with other stakeholders. I use their assets, I access them, I invoke them through the APIs. I find it with the reference points, as you can see here. And you can see also within any stakeholder in ecosystem, if you go a level of more detail, we have what we call roles. So if, let's say, a testbed provider or domain is a stakeholder, the roles are, let's say, that are inside the stakeholder could be broker admin for the testbed domain. It could be a testbed administrator. It could be a test case planner, etc., or the use case, test case designer. So this is the way that we go about this. And this is a perfect example of how an ecosystem is powered, extended by federation, and enabling to close the whole value chain to let players find what they're looking for to close their complete offering. Another example is what we call data-driven services. Data is the new oil, as you say, and telco data space is also another SDO that I'm working on or in, which is TM Forum. There we worked on this catalyst, and now we are running the second one. Here it's about how do operators, telcos, how do they share specific data sets and leverage data sets to enable richer services, to monetize on that, and to still do that with confidence that sovereignty is maintained, that you don't lose sovereignty over the data that you share. So here we looked at how do we build, let's say, a federated service catalog, as you can see in the black cloud. What are the ways of interaction in this ecosystem of multiple, let's say, telcos or CSPs, in order to establish a trust relationship, in order to negotiate what data should be shared for what purpose. So that's what we call the federation governance scope, defining this frame with dotted lines. And then the solid lines are then the data itself that you really share and put forward to enable more data-driven services and to monetize. So it's another example where an ecosystem is extended through telco data space, data sharing, building, let's say, a governed environment where you are ensured of sovereignty maintenance, and at the same time, you can put forward data to monetize and do new kinds of services. including, say, analytics, or optimized roaming, energy efficiency. There are many cases that we showcased here, but the model itself is like this. It all stems from the ecosystem evolution aspect. And finally, to conclude and wrap up, I would like to say that ecosystems, or to put your attention to the fact that ecosystems, they are really evolving very dynamically. And the partnership aspect, which is the core subject of this topic, it's gaining a key role because this also becomes dynamic as they evolve. And it's always important to close the value chain. You have to have the complete spectrum and the complete value offering in your end-to-end service. So that's why you need to really find the right partners quickly and integrate them in a seamless manner, and to maintain your competitive edge. Otherwise, nobody will buy those services. Federation is a key instrument, and asset sharing as well. And there are other, let's say, dynamic, what I call usage metered models. So some things you need to use or access to in your value chain for a specific frame of time or a specific asset, not everything. So being flexible and granular is very important. And this is, of course, for all beyond 5G ecosystems. And that's where you need to foster those partnerships and keep this a dynamic loop. We have, of course, new use cases and service models and business models that are driving the evolution of CSPs from telco to techco. And this also paves the way for new ways of partnering and new, let's say, quantities of possible partnering models and constellations, which should be kept alive. And then finally, it's very encourageable because I'm doing this also myself, working in different SDOs, the likes of Etsy, the likes of ITU, IEEE, and NJMN, which was, I think, no, they mentioned GSMA, and other, let's say, SDOs. With stakeholders, we work closely with others like ISVs and even vendors. And this is important to really standardize all these processes and the way that ecosystems are, let's say, set up, built, and leveraged. That's why it's important to really be here working in a standard direction, to have more reuse and more, let's say, outreach for other beneficiaries from the work we do.